So to describe the contribution of energy sources when metabolism is outside of steady state, I want to take a little bit of a step back and kind of discuss the goal of metabolism and why steady state is important. So first, we can say that if you look at the first line here, goal of metabolism is to accurately measure the total amount of energy we are producing in any given exercise. So for example, we want to know how much ATP or calories are we burning when we go run a mile at 7 miles an hour, for example. However, we should be aware that there are two categories of ATP production, both oxygen-independent anaerobic and oxygen-dependent aerobic metabolism. And so that's important to note that when we kind of think about this total amount of energy, both anaerobic and aerobic have the ability to provide ATP in order to meet our demand for energy for that exercise. We've covered this idea that the measurement of oxygen consumption, otherwise known as VO2, gives us the ability to accurately measure ATP produced in aerobic metabolism only. So again, that idea is a basic concept. VO2 is equal to the rate of ATP production through aerobic metabolism. But since we've already highlighted, since there are two types of metabolisms, how can we accurately measure energy production during exercise? The key to that, the answer to that question is that we have to have a scenario in which only one is producing most energy. And so that brings us to the concept of steady state. And so when we look at oxygen consumption at the beginning of exercise, it typically looks something like this. So we begin exercise, we have a rapid rise followed by a plateau. And again, we can draw lots of stuff on here as we did in class. So about 2 to 3 minutes. Sorry, now I go to using my computer mouse and it's not so good. We plateau, and when we plateau, we say that we are in steady state, right? And so hopefully you wrote down in your notes that steady state can be defined two ways. The first is that steady state tells us that there is a plateau in oxygen consumption for a given workload. Again, we say do this exercise, maybe run at 5 miles an hour. It requires this much energy, and we know at steady state our oxygen consumption plateaus. And then we get the second definition that says during steady state metabolism, almost all energy is being created from aerobic metabolism. So ultimately what we can say is if we measure VO2 during steady state, it is exactly equal to the rate of ATP production. Not only is it equal to ATP production in aerobic metabolism, but since we defined it as almost all ATP is produced via oxidative metabolism, we can say when we measure energy production, or when we measure oxygen consumption in steady state, we're accurately measuring practically all ATP and allowing us, therefore, to meet our goal of measuring the total amount of energy produced during exercise. However, the question about this really pertains to this beginning part, right? And so this idea is that oxygen consumption, as we thought about it in class, follows this given pattern where we get this rapid rise. And the way I use to define it in class is to call it the choo-choo train. So it starts slowly, and builds until it reaches full speed. However, if we think about it in terms of the amount of ATP that we had to produce, steady state tells us that we needed to produce kind of this amount here, right? That we needed that amount, and we're able to produce that amount of energy. And so we say, okay, how can we produce it? And so if we think about on this half of the graph, this shaded half, that this part of the graph, the ATP being produced is being produced through our two systems. So it is a combination of both anaerobic and aerobic metabolism producing the energy. And so, again, the idea is early on, we require anaerobic energy sources to provide a substantial amount of ATP. Once we reach steady state, we rely almost all of our ATP is being made through aerobic metabolism. And so hopefully that answers your question.